Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Ruby laser. Let's begin. Ruby laser, that is the first successful laser, and that laser is constructed by using the crystal ruby. Ruby is a crystal, and it was invented by the scientist T.H. Mayman in the year of 1960. Laser, the full form of laser, as light amplification by stimulated emission radiation. Light amplification by the process of stimulated emission radiation is known as laser, and we classify laser as gaseous laser, solid laser, as well as chemical laser, but Ruby laser under the category of solid laser, as ruby crystal is used in this type of laser. The construction of ruby laser: an active working material, here is the ruby crystal, that is a rod of ruby crystal. What is ruby crystal? It is basically aluminum oxide, Al2O3 crystal. In that of aluminum oxide crystal, it is doped with 0.05 percentage of chromium atoms, and chromium ions, the active material in that ruby, are chromium ions Cr+++, and the color of the ruby crystal depends upon the content of chromium in it. What amount of chromium within that crystal, that depends what intensity of color of that ruby crystal. When the ruby crystal contains 0.05 percentage chromium, its color will be pink. Ruby crystal are a rod with varying length and diameter. In ruby laser, used a pink rod. A pink rod whose length around 4 centimeter and its diameter generally 0.5 centimeter. And these two faces are silvered. One face is fully and another face is partially. That end is the fully reflecting end face, and that end is partially reflecting end phase. Next component, a resonant cavity, that is made up of fully reflecting plate at the left of the ruby crystal, fully reflecting plate, and partially reflecting plate at the right of the ruby crystal, partially reflecting plate at the right of that of ruby crystal. Both the plates are optically plane and exactly parallel to each other. These two planes are optically plane and exactly parallel with each other. And it is situated in a glass tube. It is a glass tube. Pumping source, a helical xenon flash tube with power supply source. A xenon flash tube with the xenon flash tube. We use the power supply as a capacitor in order to charging and discharging, that is supplied by a power supply unit by taking the battery resistor, power supply. That is the ruby rod. This one is the glass tube. Next, cooling system, water circulating system in glass tube surrounding it. Why cooling system is used? Since the ruby rod is surrounded by a helical xenon flash tube which provides flash lamp, is used in that of pumping. Here chromium ions, Cr++ ions, while the heating is occurred due to that of chromium ions. Since to avoid such kind of heating, we use the cooling system. Cooling system. Around that of glass tube, the water. Cooling. Cooling arrangement is used for that purpose. That will be the construction. Ruby rod, that is fully reflecting end phase, partially reflecting end phase, and finally the laser light is emitted with the laser beam. Glass tube, power supply unit, xenon flash light, then cooling system. Next, the working of that of ruby laser. Working. Ruby is a 3-level laser system. In the previous video lecture, we have known what is 3-level laser system. So, the basic working of that of ruby laser based upon that 3-level laser system. Since its laser action due to the component of chromium ion, basically that laser action due to that chromium ion which is doped to that of aluminum oxide Al2O3 crystal, through which that ruby crystal is made. Then its working can easily explained by the energy level diagram of that of chromium ion. So, what is the energy level diagram of that of chromium ion? It has two main bands, one is blue bands and another one is green bands. These are the excited energy states of that of chromium ion, and these two bands about 1000 angstrom wide, which makes the optical pumping effective. Let me draw that of energy level diagram. Here is the ground state. That is the excited states. Named as E1, E2. Let E1, that is the blue band, and E2, that is the green band. In between these two bands, there will be a difference of 1000 angstrom due to make that pumping is optical pumping, as we use the xenon flashlight. To effect that optical pumping, there will be a difference of 1000 angstrom in between blue band and green band. So, the ground state level of chromium, by taking energy due to the process of optical pumping, it is towards that of excited state. One is blue band and another one is green band. Here blue light, there green light. and these excited states have their own metastable states. It has the metastable states. The metastable state the atoms are in that of excited state around 10 to the power minus 8 second, and same thing after the time duration they are towards that of metastable state, and they stay at that of metastable state around 10 to the power minus 3 second. Therefore, a huge time difference in between these two states. As a result, due to that effective pumping, a huge number of atoms are now accumulate at that of metastable state as comparison to that of ground state, and the phenomenon of population inversion occurred. It is due to that of spontaneous emission. Finally, they are towards the ground state by releasing energy of photon. In between these two metastable state, there will be a difference. That difference is about 29 centimeter inverse. It has a wavelength at lambda 1, that is around 6943 angstrom. It has the wavelength lambda 2 as 6928 angstrom, that is nothing but red light. So, we obtain laser by using that ruby crystal. That is the working process of ruby laser, and that working process is based upon 3 level laser system 1, 2, 3. Now, the drawbacks and advantages of ruby laser. Ruby laser has low laser efficiency and it requires high pumping power, and the output is not continuous but occurs in the form of pulses of microsecond duration. Let me understand it. Here we use the xenon flashlight by taking the power supply unit. If we plot the graph in between time and power supply unit, so the graph is just like this. And that phenomenon, that process during a short period of a few tens of milliseconds, in which it is high and then low, high and low, intensity high and high intensity emissions and then low. These are known as the phenomenon of spiking. Due to that, the laser output is not continuous but occurs in the form of pulses of microsecond duration. That is the drawbacks of ruby laser. The defects due to crystalline imperfection is also present in this laser. Defects due to crystalline imperfection, it is doped by that of chromium ion, it is around 0.05 percentage. Due to the imperfection in that of doping, there will be a defect. Next, advantages of Ruby laser. Ruby laser is very high output power, that is a order of 10 kilowatt to 1000 kilowatt, and this type of laser are used for holography, industrial cutting and welding purposes. These 2 points are the advantages, or we can say the applications of Ruby laser. So, with the help of this video lecture, we understand the concept of Ruby laser, its construction, working, and the working process is easily understood by taking the energy level diagram, drawbacks as well as advantages. So, with this useful and informative notes, let me wind up this session. Thank you.